We were studying this example. So 5 divides n raised to 5 minus n for every positive integer. Okay, this is what the example that we were studying in the previous class. So let us take that the statement as Sn such that n square minus n divisible by 5. So I'll check the result is true for n is equal to 1. That is 1 raised to 5 minus 1. So 1 raised to 5 is 1, 1 minus 1 is 0. So 0 is divisible by 5. Therefore, result is true for n is equal to 1. That is, S of 1 is true. Next, assume the result is true for n is equal to k. The result is true for n is equal to k. So, write it sk such that k raised to 5 minus k is divisible by 5. Or you can write the same thing you can write it as sk such that k raised to 5 minus k is equal to 5a, because whenever it is divisible by 5, the things whatever we are getting, it should be multiple of 5. So 5 into a, where a belongs to z. That is what the meaning. Next we'll go for even sk plus 1 is also divisible by 5. So sk plus 1, so wherever k is there, write it k plus 1, k plus 1. Okay, k plus 1 raised to 5 minus k plus 1. So we will show that this whatever this term is there, this is a multiple of 5 or divisible by 5. Okay, next, that is k plus 1 raised to 5. How I am writing is that k plus 1 the square, k plus 1 the square into k plus 1, because many of them don't know the binomial theorem. If you know binomial theorem, expand it directly. So if you don't know it, so what you can do, you can split raised to 5 as a 2 plus 2 plus 1. That is 4, 2 plus 2 4, 4 plus 1 is 5 minus k plus 1. So friends, listen here. So 1k plus 1, 1k plus 1 is common, that you take out. So whatever there inside you write it. K plus 1 the square into k plus 1 the square minus 1. So k plus 1, we know that k plus 1 the square can be written as a plus b the square. So that is a square plus b square plus 2ab. That I'll write it in this packet. Again this a square plus b square plus 2ab minus 1. So next thing is that, again what I will do, k square into this, 1 into this, 2k into this term. Okay, so first thing you can see here, k square into this term, k square k raised to 4, k square into 1 k square into 2k is 2k cube. So after this, okay, so 1 into k square plus 1 plus 2k, that is k square plus 1 plus 2k only. Next, what is that is 2k. Next 2k into this, that is 2k into k square, that is 2k cube, 2k into 1 2k, that is 2k into 2k 4k square minus 1. So next thing is that k plus 1 into here what all the things will cancel, plus this plus 1 minus 1 will get cancels, k raised to 4 k square plus k square plus 4k square, that is 6k square. K cube means 2k cube, 2k cube, 4k cube. Next 2k 2k, that is 4k. Okay, so next thing is that, okay, so again you multiply k into this term, that is k into k raised to 4 k raised to 5 plus 4 k raised to 4 plus 6 k cube plus 4 k square plus 1 into this term. Okay, so finally after all simplification of this, what I am getting, k raised to 5 plus 5 k raised to 4 plus 10 k cube plus 10 k square plus 4k. Friends, listen here, what we have to do is that, here one trick you should remember. First I want k raised to 4, k raised to 5 minus k. Okay, minus k is not there here. So because of that, what I will do is that minus k and plus k, I'll subtract and I'll add it. So this sentence remains the same. Everything except addition and subtraction, everything we have to write it same. So what you can do is that add and subtract. Okay, so you are going to get like this, and the remaining terms, this term, you write it same as it is. Okay, so therefore this term I'll combine, these two I'll combine it. Okay, so therefore k raised to 5 minus k, see 5k raised to 4, 10 cube 10k square, 4k plus k, that is 5k. So here what is the thing is that here this means what, this, that is 5a from equation 1, and here 5 is common. So what I will do is that we'll go for the next page. See here 5a, okay, 5 is common, so this term, so between these two 5 is common again. See, between these two 5 is common, so a plus k raised to 4 plus 2k square, everything. So this term I'll take it as b. 5b is a multiple of 5 where b belongs to some integers. Okay, so you can see equation 1 and 2. So sk plus 1 is true. So by mathematical induction, okay, Sn is true for all n greater than equal to 1. So next thing is that next example we will study. This example, see, this example is asked in the exam. Okay, please be prepared. So next, the things are very simple here. Okay, so 6 raised to n plus 2, 7 raised to 2n plus 1 is divisible by 43 for each positive integer. Okay, let us take Sn is equal to this, divisible by this is divisible by 43. So test the result for n is equal to 1. So wherever n is there, write it 1. So 6 of s of 1 is equal to 6 raised to 1 plus 2, 7 raised to 2 into 1 plus 1, that is 6 cube plus 2 ones are 2 plus 1, 7 cube. So 6 cube is 216, 7 cube is 243. So when you add both, what you are getting, 559. So just 559 is divisible by 43. If you do 559 divided by 43, you are going to get it as 13. So that's what I wrote it here for your convenience. Okay, therefore I can conclude that S of 1 is true. So next, assume the result is true for n is equal to k. So wherever n is there, write it k, that is sk such that 6 raised to k plus 2, 7 raised to 2k plus 1 is divisible by 43, or sk is equal to 6 raised to k plus 2, 7 raised to 2k plus 1, that is equal to 43 into a. So this I can write it as 43 into a because it is divisible by 43. So sk plus 1 is equal to 6 raised to, wherever k is there here, wherever k is there, no, replace k plus 1, replace k plus 1. So k plus 1, 2 into k plus 1 plus 1. So that is 6 raised to k plus 3, 7 raised to 2k plus 2 plus 1. So 6 raised to k plus 3, 7 raised to 2k plus 3. So here it is very important. What is the standard form, you tell me? K plus 2 and 2k plus 1. So from k plus 3 I can write, to get k plus 2, this I can write it like this. This I can write it like this. Okay, now what we will do is that we will separate it. 6 raised to k plus 2 into 6, 7 raised to 2k plus 1 into 7 square. So 6 is 6 only, 6 raised to k plus 2 plus 7 square is 49, 7 raised to 2k plus 1. So 6 raised to k plus 2. So here it is very important. Please split 49. Please split 49. So how to split it? 6 plus 43 into 7 raised to 2k plus 1. 6 into 6 raised to k plus 2. 6 into this, 43 into this. So I'll write it like this. Okay, so here you can see between these two, 6 is common. 6 raised to k plus 2, 7 raised to 2k plus 1. So plus 43 into 7 raised to 2k plus 1. So friends, from equation 1, 6 raised to k plus 2 plus 7 raised to 2k plus 1 is 43a. 43a. So this is 43, 7 raised to 2k plus 1. So between this, again 43 is common. Between this step, 43 is common. Okay, so that is 6a, 7 raised to 2k plus 1. 43. So this can be written as, this can be written as b. Okay, 43b, where b is equal to 6a plus 7 raised to 2k plus 1, which belongs to an integer. So 43b means it is a multiple of 43. So you take any integers. Okay, so again you conclude from equation 1 and 2, sk plus 1 is true by principle of mathematical induction. Sn is true for all positive integers. Okay, any doubts? Hello? Hello? Any doubts?
No.
Okay, fine. So this, you take it as a homework. Okay, try it. Okay, and by splitting here, you carefully split it and write it. So it is divisible by which number? It is divisible by 43. So 43 plus, you can split it as 49. One can ask that 49, sir, I'll split it as 48 plus 1. You can split it in any way, but for my convenience, what I'm doing is that as it is divisible by 43, so first you write it 43 first. Okay, for that, how much you have to add? 6. So it becomes 49. So the later in the future, whatever the calculation you are doing here, so it will be easy. That is the intention. Okay, so similarly, you work out this. Similarly, you work out this. Okay, so hope you don't have any doubts. I'll move further. Okay, so one more example here, that is, show that if n is greater than or equal to 24, then n can be written as sum of 5s or 7s for all n belongs to z plus. This is a question paper example and it is bit different. If you want to see in detail, I'll give one more proof of this. So that is there in the DSC, still I have not copied it. I'll copy it and I'll write it systematically. So time being, you take this as a proof. This is definitely, this is a correct proof only, but one more proof is there. So which one is convenient for you people, that one you refer and you can interpret in the exam. Show that if n greater than or equal to 24, then n can be written as sum of 5s and or 7s for all n belongs to z plus. So write the statement, let Sn n greater than or equal to 24, n greater than or equal to 24 and can be written as sum of 5s and 7s. So time being, since n is greater than or equal to 24, we consider n is equal to 24 initially. So later greater than or equal to that, all the things we will study. 24, I had to write sum of 5s and 7s. So 5 plus 5 plus 7 plus 7. See, you can see 5 plus 5, 10. 7 plus 7 is 14. 10 plus 14 is 24. So this is 24, I am splitting like this. Next, 24, we will write it as 2, 5 and 2 sevens. So what is the statement? It can be written as sum of 5s and 7s. So I am writing like this. Therefore, please treat this S of 24 is true. Now you take, assume the result is true for n is equal to k. Okay, the result is true for n is equal to k. So 24 you take something called k. Okay, and this p of 5 plus q of 7. So what is n can be written as? N can be written as sum of 5s and sum of 7s. So n is nothing but k. N can be, so this k or n can be written as sum of 5 and sum of 7. This is the statement that I am writing here, where PQ belongs to Z and P is greater than 2, Q is greater than 2. Next, I'll try for K plus 1. Okay, so here K means what? P of pi plus Q of 7 plus 1. That's what I wrote it here. Okay, next. Here, so this star mark I have given you. This is very important. P of 5 plus Q of minus 2 plus 2 into 7 plus 1. P of 5. So I'll bracket these two one bracket, these two one bracket. So plus 1. So P of 5, Q minus 2 into 7. 2 into 7 is 14 plus 1. P of 5, Q minus 2 into 7. So 14 plus 1 is 15. So P of 5, Q minus 2 into 7 plus 15, I'll take it as 3 into 5. So finally, this is 1 5, this is 1 5, means 5 is common. P plus 3, Q minus 2 into 7, where P plus 3 belongs to Z, Q minus 2 is also belongs to Z. So here this adjustment, try to remember this adjustment. Okay, so therefore from 1 and 2 we can conclude that S of k plus 1 is true. Therefore by principle of mathematical induction, Sn is true for all n belongs to Z plus. For all n belongs to Z plus. Okay. So next we'll go for the next example. I hope this is, yes. Hello.
Sir, why you taken minus 2 and plus 2, sir?
Just for an adjustment. So it is just for an adjustment. So still if you are having a confusion, I'll send one more proof. Okay. Hello.
Yes, sir, it is confusing only, sir.
Which this example is confusing.
Sir, P plus 3,
Yes,
how you
sir.
got?
Okay. One more proof I'll send it to you. Which one is that one is easy. That is from DSC. Okay. If you are
Yes,
not
sir.
if you are not getting this, I'll send it one more proof. So next example is,
Yes.
okay, fine. So only I'm not sending the notes. I'm writing everything in detail. So once only I'll send it the DMS notes. Okay. So Sanjana, you were asking yesterday this question. Sorry, the notes, no. So I'm writing it in detail. Okay.
Yes, sir.
Okay. And before exam only I'll send it. Don't worry. So let A naught is equal to 1, A1 is equal to 2, A2 is equal to 3 and AN is equal to AN minus 1 plus AN minus 2 plus AN minus 3 for n greater than or equal to 3. Prove that AN less than or equal to 3 raised to n for all positive integers. For all positive integers n. So let us take this, we have to prove it. So which one? This we have to prove it. Is it right? So let S of n such that an less than or equal to 3 raised to n. So let us check one by one now. Let us check one by one. So that is S of 1. First S of 1. What is S of 1? A1 less than or equal to 3 raised to 1. So what is A1? A1 is 1. Already it is given. Okay. Less than or equal to 3. Is 1 less than 3? Hello?
Yes, sir.
Yes, sir.
Okay. So that's what I written here. Next, you can see here. First one is A naught. A naught. A naught less than or equal to 3 raised to 0. A naught means what? So given thing A naught means what?
1.
0.
A naught is 1. 1.
Sir, A naught is
Okay, fine. Less than
1,
equal
sir.
to
1, sir.
anything raised to 0 is 1. Is 1 is equal to 1?
1.
Correct. Yeah, 1 is equal to 1. This you leave it. 1 is equal to 1 is there. Less than or equal to both the
Yes.
either it is less than or equal to any one condition you take. 1 is equal to 1. From this what we are getting? 1 is equal to 1. That's what I wrote it here. 1 is equal to 1. So first condition I have verified. Next, A1 less than or equal to 3 raised to 1. Okay. A1 means what? 2 less than or equal to 3. 3 raised to 1 is 3.
3 raised to 1.
2 is less than 3. Is it true? Correct? No, it is. Okay, that's what I wrote it here. First condition, second condition. The third condition is n equal to 3. N equal to 3. 1, 2, 3. Okay. So that is, you take A2 less than equal to 3 square. A2 means what? 3 less than equal to 3 3 is a
3
9.
3 is less than
3
9.
3 is less than 9. So these all three conditions are true. Is it right? So S of 1 is true, S of 2 is true, S of 3 is true. So I can conclude that S of 1 is true, S of 2 is true, S of 3 is true. Now assume that result is true for n is equal to k. That is S of k such that ak less than equal to 3k. Okay, that is given. So given thing is what? So this is given, and this is also given. Any one thing we have to use it and we have to write it further. So n is equal to k means ak less than equal to 3k, we have to prove it. This is fine, but with the help of this I have to prove this. So you take help of these three and this and prove this. So in the first in the first thing, okay, I have taken help of this, and to prove next I'll take help of this. So that is an is an minus 1 plus an minus 2 plus an minus 3. I'll take n is equal to k. Ak is equal to ak minus 1 plus ak minus 2 plus ak minus 3. Okay, so you can see here, first you leave it. Okay, ak plus 1 I want. K is replaced by k plus 1. Ak plus 1, a k plus 1 minus 1 plus a k plus 1 minus 2, a k plus 1 minus 3. So you simplify. First you don't concentrate this. You don't concentrate this. Just I'll rub it. Okay. Think that it is not there. So directly you come here. K is replaced by k plus 1. So after replacing k plus 1, okay, so ak plus 1 is equal to minus 1 plus 1 get cancels, ak. So this is ak plus 1 minus 2 is minus 1, ak minus 1. So plus 1 minus 3 is minus 2. So this is coming, right? So after all this, you take help of this. What is proved here in equation 1? Ak is less than or equal to 3k. Similarly, ak minus 1 less than or equal to 3 raised to k minus 1, which is less than or equal to 3k according to inequalities. Ak minus 2 is also less than or equal to 3k. Ak minus 3 is also less than or equal to 3k according to inequalities, and whatever this is there. So ak is less than or equal to 3k. So that I'll substitute here. ak minus 1 less than or equal to 3k. I'll substitute here. ak minus 2 less than or equal to 3k. I'll substitute here. So less than or equal to, see here equal to symbol earlier. Now after replacing this, less than or equal to I am writing 3 raised to k, 3 raised to k, 3 raised to k. How many 3 raised to k are there? There are 3. There are 3 raised to k. So less than or equal to, bases are same, I can add the powers. So 3 raised to 1, 3 raised to k, that is 3 raised to k plus 1. So as ak less than or equal to 3k I had done it. So similarly ak plus 1 less than or equal to 3 raised to k plus 1 had done it. Therefore you compare this equation and this equation. So from one end to sk plus true. Therefore by the principle of mathematical induction, Sn is true for all n belongs to z plus. Sn is true for all n belongs to z plus. So these are the examples based on mathematical induction. These are the example based on mathematical induction. I hope this example you did not understand. Okay. this example. So once again I'll rewrite, okay, in detail I'll write it. If you want this all the things why they are added -2 +2, so to see the nature of that one, so you have to do in detail workout. So I had gone here directly some of the steps I written. I thought that you people will come to know. So because of that, I'll write it in detail from DSC and I'll give it to you. Any doubts? Apart from this, any doubts? You are free to ask. Yes. Any doubts?
No, sir.
Okay. Um, Taranam, Ambika, Taranam,
Yes,
Yes,
sir.
sir.
any doubts?
No, sir.
No, sir.
Arun,
No, sir.
Jyoti,
No, sir.
Kirti,
No, sir.
Kiran. Okay. So,
Yes, sir.
okay, fine. Sanjana, Shashank, I think they are replying. So anyway, so we will continue in the next class. Okay. Okay.
Yes, sir.
Okay. Thank you.